Okay, we've learned two addition rules, war and get mugged twice. We've learned two subtraction rules, type 1 subtraction and type 2 subtraction. And you're going to be able to put all of those to the test tonight with section 2.4, adding and subtracting matrices. That word matrices is the plural of matrix. And hopefully some of you guys have seen the movie The Matrix. And so I'll begin by asking you, what exactly was The Matrix? If you saw the movie, The Matrix was a sort of a computer simulation that led people to believe they were in reality, but when in fact they were really just subject to these programs. And one of the reasons they called it The Matrix is because in the computer simulation, everything was arranged with code, and you saw all these streaming green symbols and numbers and letters that made up this very, very dynamic and complex computer code. And that was the Matrix. And one of the things I want to point out was, the Matrix is taking information and organizing it. And even that green code was organized in sort of a vertical and horizontal framework. So your homework won't be as complex as the movie, but the concept will be the same. In other words, in a matrix, we are taking information and we are organizing it horizontally and vertically. All right, so let's get into the definition. A matrix is a rectangular arrangement of numbers into horizontal rows and vertical columns. And I'll stop there. You guys should know the difference between rows and columns. Columns imply that it's a vertical structure. Rows implies that it's a horizontal structure. And you do need to know the difference between rows and columns when it comes to naming your matrices. Each number in a matrix is called an entry or an element, and that's just vocabulary that we will be using. The size of a matrix will always be described as follows, and it must come in this order. We'll always go with the number of rows first by the number of columns. Let's take a look at an example of what we're talking about. So this is a mathematical matrix. Notice that you have how many entries inside of it. Well, if you count up those digits in there, it looks like we have 6 entries, or what we would call 6 elements. And this is a 3 by 2 matrix. Not a 2 by 3, but a 3 by 2. We always start with the number of rows, and we can see here that we have 1, 2, 3 rows. So that's where this 3 is coming from. Okay. Then we go to the number of columns, and we have 1, 2 columns, and that's where this number is coming from. So it's important to recognize that we're talking about a 3 by 2 and not a 2 by 3. Okay, well, one thing we're going to do with matrices tonight is we will practice adding them and subtracting them if they are able to be added or subtracted. So to add and subtract matrices, they must have the same dimensions. If they do have the same dimensions, so if this condition is met, then you can add or subtract corresponding entries. Let's go ahead and take a look at an example. So here, are we adding or subtracting? Well, if you look at the operation, this is the operation that they want you to use with the two matrices. So they want you to subtract these two matrices. But before you start doing that, you have to figure out if they even can be subtracted. And that goes back to the dimensions. Okay, so let's start with the first the first matrix on the left. What are the dimensions of that first matrix on the left? Well, we have 2 rows, and it looks like 2 columns. So that is a 2 by 2. And what are the dimensions of the matrix on the right? Well, it has the same dimensions. So it looks like the matrix on the right is also a 2 by 2. If those dimensions match up, then you are allowed to subtract them, or in some cases add them if it were an addition sign. Okay? So how do you go about doing that? Well, it says that you're allowed to add or subtract corresponding entries. Well, what do you think that means? Well, for example, here in the top left we have a 12. Okay? 12 is going to subtract some number. It's going to subtract the corresponding position. So the 12 will match up with the 4 because the 4 is also in the top left. So in this case, we're going to do top left minus top left. And 12 minus 4 is how much? Well, it's 8. I'm going to put my answer 8 in the top left of my answer matrix. And then you can proceed to do top right minus top right, bottom left minus bottom left, bottom right minus bottom right. So I want you to go ahead and try this on your own to see if you can come up with the correct answer the first time. Go ahead and try that and hit pause now. Okay, let's take a look at the final answer and see if it matches up with your own. Okay, so the answer matrix going across in rows will have 8, negative 11, negative 6, and 25. And I just want to make sure that everyone understands exactly where those numbers are coming from. So we already talked about the 8. That was 12 minus 4 produces an 8 in the top left. Okay, now for the top right answer, we have negative 4 minus 7. Negative 4 minus 7, that's type 1 subtraction that turns into get mugged twice. You lose 4, you lose 7, you've lost 11. So top right minus top right gives you that. And you can see where the subtraction rules and the addition rules really matter here. Otherwise, you could mess up. And you know, the way I grade these matrices, if you have one entry that's incorrect, the whole thing is wrong. So you have to be very precise here. All right, bottom left, negative 3 minus 3. That's also type 1 subtraction. Negative 3 plus negative 3. That's a get mugged twice. You lose 3, you lose 3, you've lost 6. So don't forget your rules there. All right, last one, we have 17 minus negative 8. That's type 2 subtraction, turns into 17 plus 8, and that's where we get the 25 from. Okay, so hopefully you got the first one right. You do have to get all entries correct in order to receive credit. Okay, I'm going to give you 2 practice ones to try on your own. These are blue examples, so you do need to turn these in tomorrow. So go ahead and have out that piece of paper and pencil. It says, can these be added or subtracted? Well, that's a yes or no question. So you'll begin by saying yes or no. If they can be, then go ahead and add or subtract them depending on the plus or minus sign. Okay, so go ahead and try these on your own. We'll reconvene, but go ahead and hit pause now, and then we'll reconvene to do answers. Okay, so in number 1, we are attempting to add those 2 matrices. So first of all, can they even be added? So let's go back to the dimensions. What type of matrix is number 1? Well, hopefully you realized that it is a 3 by 2. 3 rows by 2 columns. And if I ask you what the dimensions are for the second matrix, hopefully you'll remember that this is a 2 by 3. Are these dimensions the same? No, they are not. They have to be exactly the same in order for you to be able to add these. Okay, so we're not going to be able to add these. So you could answer this with maybe something like not possible. You're not going to be able to do number 1. Now let's take a look down at number 2 and see if these match up. Well, dimensions for number 2, the first matrix. That's a 1/2, a 13, and a negative 18 on the top row there, a 0, negative 2, and a 6 on the second row. Looks like we have 3 rows by 3 columns. And for the second matrix, we also have a 3 by 3. So since our dimensions match up exactly, we will be able to perform an operation here. And the operation they are asking us to perform is subtraction. So in number 2, we are subtracting. So let's go ahead and compare our answer matrices. My answer matrix is also going to be a 3 by 3. And I'll go ahead and do this in rows. So top left minus top left, 1/2 minus 2 is going to be negative 1 and 1/2. Now, if you answered with negative 3 over 2, that's completely fine. If you answered with negative 1.5, it's okay, but it was given to you as a fraction, you should answer as a fraction. I'm going to kind of tell you that in most cases, fractions are better than decimals, so you want to practice your work with fractions don't get scared and try to run off to decimal land because you feel more comfortable there. Push through, practice the fractions. It's going to make you better, especially second semester. All right, top middle, 13 minus 20. That's type 1 subtraction. We're going to get -7 there. Top right, -18 minus 3. It's going to turn into get mugged twice. And you're going to end up with -21. All right, middle left, 0 minus 5. Type 1 subtraction. It's going to give you -5. -2 minus -7. That's type 2, turns into -2 plus 7, and that gives you +5. And then 6 minus 1, that's second grade, also gives you +5. Notice we're going to have 9 elements here. It's really easy to screw up on one of these. The most common mistake is you'll look at the wrong number and start subtracting 2 of the wrong numbers. You've got to match up the positions and make sure that you're not out of order. And even I mess up on these from time to time. So if you see me mess up, please speak up in class. All right, bottom left, 5 minus -1, 5 plus 1, that's going to be 6. -7 minus 6. Type 1 that turns into get mugged twice. -7 plus -6. You lose 7, you lose 6. You've lost 13. And then final entry, 4 minus -11. That's type 2 subtraction. 4 plus 11 is 15. Okay, so make sure that you got all 9 elements correct, and if you did, then you would get credit. Even if you missed just one, it's going to cost you the whole thing. So make sure you always double check your matrices. All right, let's go ahead and move on to some more examples. These I'm going to have you copy down with me. They're a little bit more involved. So you can copy along with me, and they will be able to be added or subtracted. So I'll go ahead and tell you that. All right, number 1. Number 1, we're going to have a 3 by 3 matrix. So you can go ahead and start copying this. And we'll do -6, 2, and 2/3. 4, 0, and 7, 13, -5, 3 1/2. So you're going to have to work on your fractions here. There's no way around it. Okay, and we're going to add this to another 3 by 3 matrix. And here are the entries. 3, -10, 3/4, 1/2, -3, 7, -8, -7, 5. You are required to copy these down, not just give me the answer. That's why I'm going slow with you. Okay, let's go ahead and copy the second one as well, and then I'll let you have some time to work on these on your own. Number 2 is going to be a different dimension of a matrix. We're going to have a 3 by 2 with entries 8, 10, -5, 4 3/4, 6, and -4. And let's do subtraction with this one. -2, 3 1/2, 6, 2 1/2, -18, -5. Okay, you're going to need a little time to work on these, so take your time, go ahead and hit pause, and then when you're ready, we'll go over and check answers. Okay, let's go ahead and go over and see how you did. Remember, you need to have all entries correct in order to receive credit. So it's your job to figure out if you do make a mistake here, which is not a big deal, but if you do make a mistake, you're responsible for going back and figuring out, okay, where did I go wrong and how did I make that mistake? That way you're ready come test day. All right, I'm going to give you these in terms of rows. So for number 1, your 3 by 3 answer matrix should be -3 in the top left, 4 1/2 top middle, 5, -8, -3, -12, 17/12. You could also have written that as 1 5/12. Either way is fine with me. 14 8 1/2. Okay, so hopefully you got all 9 of those correct. If you struggled with the fractions, okay, let's talk about the 2/3 plus 3/4, because that's something that you might be a little bit rusty on, but these are skills that you're definitely going to need to have. Okay, so if I'm going to try to add 2/3 plus 3/4, okay, I might need to do a little side work on that. So on my paper, I'm doing something like this: 2/3 plus 3/4. Let's go back to 5th and 6th grade and remember, how do we add fractions like that? Well, we are going to have to get a common denominator. So with 3 and 4, what do we use as a common denominator? We use 12. And 2/3 becomes, let's see, 3 times 4 is 12, 2 times 4 is 8. It becomes 8/12. 3/4, 4 times 3 is 12, 3 times 3 is 9. That becomes 9/12. So really what I'm adding is 8/12 plus 9/12. And that's where I'm getting that 17/12 from. So if you need practice with fractions, that's something you're going to need to take care of now. Otherwise, it'll come back to haunt you later. And I don't want that to happen to any of you guys. All right, let's go over answers for number 2. On number 2, we're going to have a 3 by 2 answer matrix. And I believe the answers for number 2 are 10, 2 1/4, 6 1/2, 24, -11, and 1. So hopefully you got all 6 of those correct. If not, go back and figure out maybe where you might have gone wrong. Like I said, it's very, very easy to get confused on these. Okay, let's get some more practice now. 2 more for you, and you will need to copy these down with me. Let's go ahead and get that pencil and paper ready. You probably already have it ready. All right, number 3. I'm going to give you a smaller one here. So this is going to be a simple 2 by 2 matrix. And we'll use -5, 0, 4, and 1/4. Go ahead and from that subtract 3, -5, -7, and +7. So that's your 2 by 2 matrices for number 3. And then your last one, I'll give you something a little bit more challenging. These will be 3 by 2. Let's do -6, 5, 4, and 5/6, 0, 3, and -14. And to that, we will add -8, -5, 3 2/3, -12, 9, and 1.5. Okay, so go ahead and try those on your own, and then we will reconvene to go over answers. Okay, let's take a look at how we did. So in number 3, our answer matrix is going to be a 2 by 2. And you should have come up with -8, 11, if we're going by rows, 5, and then -6 3/4. And those bottom right numbers, 1/4 minus 7, that's type 1 subtraction, turns into a war, plus -7. Negatives win, they win by 6 3/4. All right, let's check out the last one, see how you did. Your answer is also going to be a 3 by 2 matrix. We'll go by rows. You should have -14, -12, 0, +12, 8, and 1/2, and then -12.5. That one's a tougher one to get all 6 in, particularly that 8 and 1/2 piece. So let me briefly go over the fractions. If we are going to try to add 4 5/6 plus 3 2/3, okay, I want to rewrite that with common denominators, and I'm going to use 6 as my common denominator. So the 4 5/6 won't change, but I will change the 2/3, and I'll change the 2/3 into 4/6. And I'm going to add these together. 4 plus 3 is 7. 5 plus 4 is 9 on top, 6 on bottom. 7 and 9/6, if you had that, it is correct, it's just not simplified. You do have to take this 9/6, it's an improper fraction, and you have to convert it to a mixed number. Okay, so how many times does 6 go into 9? 1 with 3 left over. And that 1 whole I'm going to add to the 7. So that 1 adds to the 7 to become an 8, and I have 3 left over. So that's 8 3/6, which reduces to 8 1/2. Okay, so hopefully you remember that from 5th and 6th grade. Good luck with your assignment. Just make sure that you double check all positions and all operations to make sure you don't make any careless errors. It's not a hard concept. You just have to cross all your T's, dot your I's, that type of thing. All right, see you in class tomorrow. Good job.